NASA was never expecting to see this on their way to Jupiter. First, let's start off with some background info. On October 18th, 1989, STS-34 took off from Cape Canaveral, Florida, carrying a very special payload, the Galileo spacecraft, which would ride inside the cargo bay of the space shuttle to low Earth orbit, where then it would be deployed by space shuttle crew in order to begin its journey to Jupiter. Because Galileo launched on the space shuttle, it was limited in how much fuel it could carry, so it needed to use less fuel in order to get to Jupiter. In order to do that, it used a more efficient trajectory to Jupiter that involved multiple gravity assists at various planets such as Venus and Earth. A gravity assist is essentially when you fly by a planet, so then its gravity pulls you in and grabs you and catches you, but relative to the planet, you're remaining the same speed and you'll fly away. But relative to the sun, you'll actually gain some of that planet's velocity, and that will push you along faster. There were many firsts that the Galileo spacecraft achieved. The Galileo would be the first spacecraft to actually orbit Jupiter. The previous missions to Jupiter, Pioneer 10, Pioneer 11, Voyager 1, Voyager 2, were flyby missions, and they would only fly by Jupiter because they didn't have enough fuel to slow down, and they were also going to different targets in the solar system. Because these missions were flyby missions, they could only spend around a day at Jupiter before they flew away. And even so, with that short period of time, a treasure trove of scientific data was revealed, including the discovery of volcanoes on Jupiter's moon Io, which is a big deal because it wasn't just volcanically active, it is the most volcanically active place in our solar system. This was interesting because Io is small. It shouldn't have enough heat left in it to cause that activity. So what they believe is causing it are tidal forces that Jupiter has on Io, stretching and pulling the surface of Io, causing massive amounts of friction and heat to generate. This is sort of similar on how our moon pulls on Earth's oceans, causing the tides. The evidence for the presence of massive tidal forces on Io also increased the evidence that potentially Jupiter's icy moon Europa could also have those same tidal forces heating up its icy surface and causing subsurface water oceans. Which is why scientists were very keen on sending a spacecraft that could orbit Jupiter and stay there for a long period of time by basically slowing down once it got to Jupiter. Another first of Galileo would be that it would deploy the first atmospheric probe to enter Jupiter's atmosphere and study it. Galileo's journey to Jupiter was certainly eventful, to say the least, because Galileo's high-gain antenna, responsible for sending all the data back to Earth that it collected, failed to open. What they believe happened was the antenna only partially opened because it was cold welded. Cold welding is when essentially two metals in a vacuum will fuse together because there is no air. Now, usually with a spacecraft, you would cover any metal components in a lubricant, so then that way when they touch another metal component, they won't cold weld to each other in space. However, the Galileo spacecraft was put in storage for multiple years following the Space Shuttle Challenger disaster, which made the lubricant less and less effective, which allowed for the cold welding to have occurred. They still tried to save the antenna, so for many months they would point the antenna towards the sun and then away from the sun in order to have the temperature difference try to change that. But none of that worked, so they were forced to use the small, tiny, itty-bitty, low-gain antenna on top of the high-gain antenna. This antenna was not made for high data rates. It was only initially planned to operate at around 8 to 16 kilobits a second. But improvements to NASA's ground antennas that could hear much better allowed us to get 160 bits per second. And then by improving data compression rates, we were able to get about 1,000 bits a second, or a kilobit. Even so, that is still a really low data rate that it didn't allow Galileo to collect nearly as much data as it could have. Even with this problem, Galileo was able to make many firsts, making one of the first close encounters with an asteroid, in this case asteroid 951 Gaspra. Later on in its journey, Galileo was also able to fly by asteroid 243 Ida, where it discovered that Ida actually had a small moon orbiting it, making it the first asteroid ever discovered to have something orbiting it. Then, as Galileo was approaching Jupiter, by chance comet Shoemaker-Levy 9 would be impacting Jupiter, when it would have a front row seat to this impact. Comet Shoemaker-Levy 9 broke up into about 21 pieces, with each impacting Jupiter. Each of these impacts were massive, producing about the equivalent explosion of 6 million megatons of TNT. These impacts generated massive fireballs that also left massive marks on Jupiter. While Galileo was at Jupiter, it was able to reveal its moons in magnificent detail. Here is a lava flow that it was able to capture that formed over the period of many months. Here's a volcanic eruption that it captured. It was also able to document many changes that occurred on Io's surface from volcanic eruptions. Galileo was also able to make a lot of discoveries and observations at Jupiter's moon Europa, providing a ton of evidence that Europa actually has a subsurface ocean beneath its surface. Galileo was also able to reveal Europa's surface in depth, showing massive icy ridges of material that's been brought up to the surface. It's because of Galileo that we have some of the most close-up images taken of Europa's icy surface. Unfortunately, all good things must come to an end, and for Galileo that meant a fiery destruction into Jupiter's atmosphere, because as the aging spacecraft was running low on fuel, basically they wanted to spend the remainder of the fuel to destroy it into Jupiter's atmosphere, and you might be asking yourself why. Well, partially because of Galileo's discoveries at Europa revealing that it could potentially be habitable to life. If Galileo was just left floating around Jupiter and it potentially hit Europa, then it could carry life that was on the spacecraft from Earth onto Europa, and then you don't know if the life that you find on Europa is from Europa or if it's from Earth. So just to save us that headache for future scientists, we destroyed Galileo by disposing it into Jupiter's atmosphere. If you find this type of stuff interesting, feel free to like and follow for more content.